Today's curiosity is accompanied by Brun Brown Ale from Section 6 Brewing Company. They're located in Brandon, Manitoba. Their tasting notes include words such as dark chocolate, coffee, and toast. Yeah, definitely getting the coffee and chocolate vibes out of that. Not so much the toast, but hey, my taste may not be all that great anyway. So today I'm going to take a look at this ancient little charger that I found lurking in the back of my closet. This one's called the Charge Pal from Pure Energy. It is designed for charging rechargeable alkaline batteries, a technology which has been out of fashion for a decade or more. This particular one claims to output 1.7 volts DC or 360 milliamps max. So I went digging on the internet for information about this, and it seems that 2004 is about the earliest that I found anything, and that's a bit of a data sheet from the company on the alkaline rechargeable batteries. There's a little bit more on Wikipedia. Let me show you. Wikipedia tells me that this particular company, a Canadian company by the way, started working on these in the late 80s and in the mid-90s started putting them out. Interesting. Unfortunately, there are several limitations to this, and this right here is one of them. Only 25 charging cycles if you let the battery go right down and then bring it right back up, and up to 500 when you optimistically just discharge it ever so slightly and then bring it back up to full over and over again. The other articles and stuff that I could find from back in like 2010 range suggest that that 500 is very optimistic. But who wants a rechargeable battery that you can only recharge 25 times? Or 50 if you're really careful. And a lot of people also complained that they leaked, and that was the thing that I remember observing too. They didn't have all that much capacity. Their capacity reduced quickly on repeated recharging, and yeah, they leaked if you weren't really careful with them. Now, the chemistry of these rechargeable alkalines is different than a standard alkaline, and even though you can theoretically recharge standard alkalines, it's not good for them, and that reduces their life even more than these things were. So seems like just a bad idea, and they got discontinued and basically replaced by nickel metal hydride, which is a much better battery technology. Link from that Wikipedia page is actually one of their data sheets for the original battery. I'll put a link to that Wikipedia article down below, and you can follow through if you want to take a closer look at this. I'm not all that versed in chemistry, but there is what was going on inside them should you happen to be more of a chemistry aficionado. But that's all right. I'm not here to use this thing. I'm here to take it apart before I recycle it and just see what's inside it. First thing I notice is there are 3 screws on the back of it, which is really nice. You don't see stuff these days so much that is just simply screwed together. The other thing I notice is it's got a little bit of weight to it, so I'm expecting to find a transformer. Yep, there we go. So we have the battery terminals for AAA and AA, positive and negative end. We have a little LED, and we do have a transformer-based power supply. Just lift this board out of here. There's not much going on in there. I might actually be able to reverse engineer this nice old school single-sided circuit board. However, in their paranoia, they have splooged paint or something onto this device here. This device, which is labeled VR1, so that's probably a 78 something voltage regulator, I would guess. What are the other components that we have in here? We have a 2N3904, which is just a common NPN transistor, and get over here. Another one, okay. Other than that, a couple of electrolytic capacitors, 25 volts, 47 microfarads, and 25 volts, 330 microfarads. And then a selection of diodes and resistors, and that's about it. Let me Let me grab a piece of paper and see if I can figure out this schematic for you. Well, that took a while. Let me just unplug this here. Just for safety. There's nothing too high voltage over here, but whatever. So I started off like this, and then I remembered that I'm trying to learn how to use KiCad or KiCad, however you want to pronounce it, to generate circuits, and this was starting to get messy, and I'd only got about a third of the components on there, so I switched over to the computer, and after a couple of hours, I've come up with this. There's a couple of mysteries in here. One of them is this VR1. I thought it was initially a standard regulator, like a 78-0 whatever, but I don't think so. I think it is actually an LM317, which is an adjustable linear voltage regulator. And the reason I thought that is because I was consistently seeing that 1.25 volts between pin 1 and pin 2, the adjustment and the output. And there is approximately how it's used in a normal circuit, although I don't think it's being used for that here. So again, between pin 2 and the adjustment pin, I was seeing that 1.25 volts, which is also across this resistor, which makes sense in that application. So I think that's what's going on. Well, let's just start from the beginning. Wall plug transformer, 7.7 VAC. That's what I measured. I'm not quite sure what it nominally is, but that's what I measured. And the resistor values are also what I measured in circuit. I could use the color codes if I wasn't colorblind. So I'm relying on what I measured in the circuit. And because of various different things in parallel with them, they may not be exact, but that's close enough for this purpose. So over here we have these 4 diodes, D1234, which form a bridge rectifier, generating this plus 9 volts DC over there against that 0 volts. And then D5 and 6 are another, basically they do the same thing as these two. So they are creating another 9 volts using these two as their 0 volt again. So basically we have one full bridge rectifier there and another one there. This 9 volts goes across the big capacitor, voltage into the regulator. This one goes down here to the LED and the base of this transistor. This transistor, as far as I can tell, is sensing the current, the charge current, sensing that the fact that there is some charge current, using this mess here to feed the base and turn the LED on and off. And that's all it's doing. That's all basically this entire section down here is doing, including C2. This part up here is what is actually charging the battery. And again, the 0 volts comes to the battery minus through this 10 ohm resistor, which is the current sense for that. And if you remember from this schematic, there's 2 resistances. There's the high and the low resistance to create a sort of a voltage divider to ground, or 0 volts, for this LM317. So one of those resistors is that one, and the other one is this plus the transistor, which is also getting its base from this 9 volt line here for reasons. I'm not quite sure why. Yeah, I'm not entirely clear why this one is using that 9 volts instead of this one, but essentially that guy gets turned on, and this resistor and this resistor create the voltage divider that tells this guy what voltage to output, which is, what did I measure it as? 1.6 volts with no load on there, or whatever it needs to be to charge the batteries up to about 250 milliamps. And then Q1, because it's got a reference through this current sense here, it is, I believe, going to be controlling this guy to limit the current to the charging. That's what I believe is going on. If somebody wants to fact check me down in the comments, feel free. I've double checked this schematic and I'm fairly confident that it is accurate. But if there's something that completely doesn't make sense, again, well, let me know. Of course, all that depends on my guess that this is an LM317 being correct. The pinout makes sense in the circuit. The tab is connected to the correct pin down here. I don't think it's going to be a power transistor because, no, that wouldn't make sense the way it's set up in there. Plus, they've labeled it VR1 instead of, if it was an actual power transistor, I would have expected it to be labeled Q3. Like these guys are labeled Q1 and Q2. Interesting also that they've got two separate 9-volt supplies in here. Not entirely sure why they decided to do it that way. Maybe they just didn't want the current sensing control for Q1 is the current sense control. Maybe they didn't want that being interfered with the actual charge current. I am not sure. Still, it's nice to see something with discrete components and a single-sided board that's relatively easy to trace. I mean, I could have carried on this way, but it would have become spaghetti, and really I would have had to redraw it 2 or 3 times to make it presentable. So I got a bit of practice in KiCad, which is something that I really, really need. Maybe one day I'll be able to generate my own circuit board with it, but in the meantime, I'm learning how to draw schematics on it. Oh, that was fun. I hope you found that interesting or entertaining or something. I don't know, does anybody else remember these things? I assume it's going to be somebody in Canada because that's where this brand was from. Apparently they licensed their technology to Rayovac in the States for a while, so you may have seen it under a different name for rechargeable alkalines, but they probably didn't last any longer down there. Yeah, so I guess that's it for now. Thanks for watching. Questions or comments, as usual, down below. I'll talk to you later.